A scientist examines a patch of mold growing in a petri dish. A hand pulls away from the sudden heat of a glowing light bulb. The moon shifts from a thin crescent to a bright sphere over the course of a month. Most of us walk right past these moments. We accept that the bulb gets hot, or that the moon changes shape, without ever pausing to ask exactly why those things happen. Science is not a static textbook of memorized answers. It is a living, breathing method of investigation, and it starts the moment you get curious enough to look closer. To see how this process works, we are going to take a journey. We will start down at the invisible microscopic level, pull out to the human scale, and keep going until we reach the vacuum of space. Mastering this single investigative mindset allows you to decipher the rules governing the entire universe, no matter what scale you are looking at. We begin inside a single drop of pond water. Magnify it enough, and a hidden, teeming ecosystem of microscopic organisms appears right before your eyes. It is easy to assume these tiny life forms are simply pathogens, microbes that cause disease. Yet many of them act as silent helpers, actively aiding our digestion and keeping us alive. In 1928, Alexander Fleming noticed something strange in his laboratory. A stray fungus had contaminated one of his bacterial plates and was actively destroying the bacteria around it. That careful observation led directly to the discovery of penicillin, the very first antibiotic. Let's push even deeper, past the living microbes, down into the water itself. Here, we find the invisible atomic particles that build everything around us. Look at this diagram comparing the three states of matter. Locked in place, vibrating tightly, you get a solid, like ice. Given room to flow loosely, they become a liquid. Bouncing freely in all directions, they turn into a gas, like steam. These particles can also join together. They exist as pure, single elements, bond chemically into complex compounds, or simply blend into physical mixtures that can be separated later. Every object you interact with is constructed from a different arrangement of these exact same microscopic building blocks. Now, let's pull back up to the human scale, right into a typical kitchen. On the counter sits a plugged-in toaster, a glass of water, and a glowing light bulb. The electric current running into these devices is a flow of energy. It meets resistance to create the heat inside the toaster, and that same current generates magnetic fields to drive the heavy motors spinning inside a blender. Suddenly, an apple is accidentally knocked off the counter. It doesn't float, it plunges straight to the floor. That fall is governed by gravity, the universal, invisible force that constantly pulls mass toward the center of the Earth. Over by the glass of water, a beam of sunlight strikes the surface. This shows us exactly how light waves interact with the physical materials in their path. This ray diagram illustrates two distinct behaviors. First is reflection, where light hits a flat surface and bounces off at an exact equal angle. Second is refraction, where the light enters a denser medium, like water, and physically bends. Your kitchen is entirely puppeteered by these specific physical forces, energy currents, and light waves. Let's scale up again. We travel out the kitchen window, punch straight through the atmosphere, and emerge into the vacuum of space. Out here, the exact same gravitational pull that dropped the apple to the kitchen floor is actively tethering the moon, keeping it locked in its orbit around the Earth. Notice how the moon reflects sunlight in this orbital model. As the Earth, moon, and sun shift relative to each other, we see different angles of illumination. Early humans tracked these lunar phases, using them to invent calendars that still organize our lives. Let's plunge back down to the Earth's surface, sweeping quickly over massive, dense green forests and wide open oceans. Down here, life operates within an ecosystem, a dynamic web where energy flows from producers, like plants, straight up to consumers. Nature is constantly reacting and adapting to new inputs. Human activities like deforestation and pollution tip the Earth's delicate climate balance. When that balance shifts, small changes in temperature can generate the extreme pressure differences that fuel dangerous cyclones. Earth's macro systems are deeply interconnected, meaning a change in a single invisible variable can redefine the environment for everyone, everywhere. From microscopic bacteria fighting off infections, to electric currents driving motors, to gravity holding our solar system, the universe operates on a single, continuous web of physical rules. Because our actions directly affect these dynamic systems, understanding these scientific principles provides the exact toolset we need to make better decisions about our health, our technology, and our changing climate. Stop passively accepting the world around you. Adopt the mindset of an investigator. Look closely at the everyday mysteries and